Hello, everyone. My name is Kevin Tarr. I'm an iOS engineer, and today is day 28 of Algorithms in Swift. So today we're going to be playing a game of Tic Tac Toe. I know this is bringing back memories from grade school, some of you even high school, but we're going to be playing a game of Tic Tac Toe, and we're going to be finding all the X's and all of the answers of all the games of Tic Tac Toe that we have. This is going to be pretty fun. This is going to test our ability to um, work with array of arrays and find elements within arrays of arrays, which could be pretty tricky, but I think that we have a solid solutions with S to solve this problem. So let's begin. Okay, guys. So our problem states: given an array of arrays to represent a game of tic tac toe, return a number of x's in all of the individual arrays. Okay. So we have a game of tic tac toe here. We have two x's in the first array, one x in the second array, two x's in the third array. That's five x's. Should return five. Two x's in the first array, two x's in the second array, two x's in the third array. Should return six. One x in the first array, one x in the second array, one x in the third array. Should return three. Okay. So this is just basically going to test um, our ability to handle arrays of arrays and just our knowledge of being able to find elements within arrays of arrays, multi-layered arrays, multi-level arrays. Okay, so I'm going to give you guys three solutions to this problem. First, I'm going to start off with brute force. Sort of, I mean, it's valid, but it's not as efficient time-wise. We could do for loop. So let's just call this find the x. Okay. Array. We're gonna name our array of arrays. It's gonna be a string type. Uh, okay. I'm gonna return an integer. Create an array. Create a variable called sum integer, and then we're going to go through the array of arrays for index n0 to array of arrays dot count for um, array n array of arrays, and that's a fact. Let's call this x count for x count and array of arrays index. Um, if x count equals x, then sum is going to be, we're going to add 1 to sum. Okay? Then we're just going to return sum. Okay? So we're going through the original array stack. Okay, so we have an array of arrays here. So we're going through the array of arrays elements. Okay, so the array of arrays first element is this array here. The second element is this array here. The third element is this array here. Okay. So we're going through its elements starting at 0, so 0, 1, 2. And then for each array that's within the array of arrays, we're we're going to go through its individual elements and ask if the element is equal to x. So let's just change the element for clarity's sake, okay? Let's just, in fact, letter, make better. So if letter is equal to x, okay? And if it's equal to x, we're just going to add 1 to sum. And we're just going to be counting some iteratively, excuse me. And that's going to give us our array count. So let's do find the x, and let's just throw this in here. Okay, let's throw the first one in. Okay. Hmm. Oh, forgot to make this an array of arrays. Sorry. All right, so let's just find The array count. Okay, we have 5 here instantly. Okay. Let's do this one. Forgot to make it array of arrays, but this should be 6. And let's do this one. Should be 3. Okay. So you may agree that this is a valid solution, 3 right here. So you may agree this is a valid solution, but this is fairly inefficient. We have to go through 2 for loops to find the element, to get down to the root of the lowest level of the array of arrays to find the elements of x, okay? Find which one equals x. So we can refactor this and just say, for index of zeros I count, instead of doing the 2 for loops, we can actually use functional programming, our best friend, and just filter through the array and find this x count. And make sum and add the count to sum. And that also gives us our x count. Okay? 3. If we do the same thing for this, should give us 6, right? If we do the same thing for 5, should give us 5. Okay? Cool. And this is a valid solution to the problem. You could get some debate about filtering and for looping in the same problem. But it's not computationally expensive. I think this is a valid solution to this problem. But if you want to do away with for loops and just get straight to a more succinct solution to this problem, there is a succinct solution that I have pulled up my sleeve. I think. We can solve this problem in one line of code, okay? So instead of doing the whole for loop complexity, we just use functional programming to make one beautiful single line of code, okay? We could do an array of arrays. We could flat map the entire array of arrays, so that just makes it one giant array rather than 3 different arrays in one array, and doing all the multi-level, it takes away all the multi-layers of the array of arrays and just makes it one single array. So we can directly ask it, we can directly filter it and ask it to give us back only the values that are equal to x. The elements are equal to x, and tell us the count of it. And that also is a valid solution to our problem. 5. Okay, let's just do this as well. Just test this. 6. And let's just do 3. Okay. Boom. So this is a valid solution to our problem. This is using functional programming to give us a one-liner succinct solution to our code. And if you want to just be ultimately safe, of course, it's always good to check to see if your array is empty to begin with, so you don't do all this hard work for nothing. So array is empty, else return nil. Return 0. And yeah, so this is a valid solution to the problem as well. And this just gives us more safety with checking to see if our array is empty for edge cases. Okay, so guys, let me know what you think of this solution in the comments. If you have any valid solutions, please, let me know. Comment as well. Hopefully, this helps you in your next coding interview for iOS and Swift. Guys, I'm Kevin Tarr, signing out. Have a good night. Bye.